We've got Ranties ready to rock and roll, aren't you, Ranty?
I am, yeah.
Right, let's get you going then while we're waiting for John.
Yeah, sure, yeah. I want to talk about diffraction because obviously the globers seem to think that diffraction doesn't play a part in losing any detail in your photography or anything like that. So this is a series of images that I took facing the same location. So I'm aiming for this cloud here, specifically in this location right where the cursor is. Now, this is without any zoom at all, and it was in 4K as well. So this is shot in 4K, so it's the highest resolution that I could get. And what we've got is we've got some smudges on the horizon. These are the wind turbines, and this is the actual location right here where I'm actually going to do a series of images getting incrementally closer. And so from this point here, you know, the angular resolution of all this stuff over here, in other words, this turbine here, this big turbine, 300-foot turbine, is in perhaps half a dozen pixels. That's all it's in. So it can't collect all the data. It just can't do it. So it's actually diffracted. So this means that all that data there's a lot of data that's being lost. It's being spilled into the neighboring pixels, and the Aries disks, all that information isn't being collected. And this is just a perfect example of the diffraction limit in action. So that's the first image. Here's the next image. I zoom in closer. And if we want to focus on something really small, which would be this little part right next to this turbine, and you can see that it's a little bit of a smudge. Again, it's not very clear. Let's go to the next image. And then when we zoom into the same location, we can actually see a lot more detail now. We can actually see that there's some kind of structure there. But if we go back a couple of images, like I say, let's go back to the very first image and we look at this, we have no idea that that structure would even be there. This is the location where it would be. It's filmed in 4K and it's not visible. It is completely invisible. And what's going to happen is that the camera will, I went into my digital, here we go. So this is in digital. And essentially this was as close as that I could get. So once we've got to this point, and this turbine here, which is some 16 miles away, we've got to this point, these turbines 16 miles away. If there was another object twice as far away, even in digital zoom, you wouldn't be able to see it. It's as simple as that. Things would be lost, data would be lost, things would be lost to diffraction. And this is just a really cool example of how that actually works.
Cool. Very cool. Thank you, Ranty. Is that the end of your bit?
Yeah. I mean, I've got loads more. I've got a load of stuff to talk about at some point, but this was what I wanted specifically to talk about today. It's just that the globers seem to think that in every image you're going to capture all the details. It doesn't, you know, there's no, you're always going to get all the details, and this is just a good example of proving that wrong. So in this image, we have no idea that that building is there or that structure is there next to that turbine. Same as your eyes, your eyes as 0.02 degrees, your eyes wouldn't be able to see it. The camera isn't able to pick it up. And at some point, all the cameras get diffracted. There is a diffraction limit to everything. And eventually, at some distance, you wouldn't be able to see anything, no matter how good your camera is.
Excellent. Absolutely spot on.
No problem.
Your timing is epic and Quantum Eraser's ready to rock and roll. Do you need to present your screen?
I didn't say I was ready yet.
Oh, we haven't bought enough time.
I know you are. Okay, listen. Yeah, let's just do it. I'll present the screen. 1 second.
Okay, give me a second, then I need to set that up. So.
Okay.
I'll just present it to the Hangout as well, just because I'm that kind of guy.
Just let me know when it's up, man.
Yeah, just give me a couple more seconds.
Yeah. Take your time. We got 4 more hours.
We haven't. Think of it as though there's 4 more hours. Right, I think we're ready to go. Right, you're on.
Yeah, so late, I think it was late yesterday, Anthony brought or made a video about conspiracy cats, right? I don't know if you guys are familiar with this one. I was checking it out later yesterday, but I was absolutely shocked at this. Now, we're talking about an educated baller now, because conspiracy cats, he's not only educated, he's teaching your kids, right? Let's see what he has to say here. Conspiracy cats. The second law of thermodynamics is about the movement of energy, not the movement of matter. I nearly fell off the chair. I couldn't believe that he actually said that. I had to go back and listen to it a few times. What the hell is he talking about? Number one, from University Today or the universetoday.com. Number one, Einstein showed us light and matter are just aspects of the same thing. Matter is just frozen light, and light is matter on the move, right? Einstein's most famous equation says that energy and matter are two sides of the same coin. So what the heck are you talking about, conspiracy cats? I mean, you're an Einstein junkie, right? Number two, from the entropy site .edu. In classical thermodynamics, it is viewing entropy increase as a measure of the dispersal of energy from localized to spread out at a given temperature, right? In molecular thermodynamics, it is considering the change in a system or surroundings or their total, for which there are fewer accessible microstates to one for which there is an increased number of accessible microstates. I mean, don't you know this? Again, from the entropy site .edu, gas expansion into a vacuum. The mixing of ideal gases or liquids, diffusion, effusion, colligative effects, and osmosis each fundamentally involves an increase in entropy due to increased dispersion of energy with no change in total energy in the case of ideal substances due to a greater number of microstates for the particular system involved. This physics teacher had failed 6th grade intro to physics. I mean, I'm speechless. Wait till you hear this one. This is the last one, by the way. Conspiracy cats. The particles that have made it that high up in the atmosphere have already done so much work against gravity and have radiated off so much of their energy as heat that they have almost no energy left whatsoever. What? Are you on medication? Dude, have you heard this before? An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. You heard this before. Number two, this gets better. Gas particles are constantly colliding with each other and the walls of their container. These collisions are elastic. That is, there is no net loss of energy from the collisions. This is intro to chemistry, by the way. And by the way, where's the container? Too funny. Number three. The average kinetic energy of gas particles is proportional to what? The absolute temperature of the gas. And all gases at the same temperature have the same average kinetic energy. So, that high up in the atmosphere, crayon munching Mr. Magoo, is the thermosphere, where temps can reach better than 3,000 degrees Fahrenheit. They're gaining energy. And number four, radiate off energy is heat to what? To what? Do you even know the 3 levels of heat transfer? Please explain that to us. And what happens to gases when they cool? After you answer that, then where's the liquid in the upper atmosphere? My word, sir. And number 5, gravity. We've been down this road before. Which gravity? Einsteinian or Newtonian? Then, is gravity a force? B, is gravity a scientific law or scientific theory? C, what is the cause of gravity? D, scientifically validate the one you choose. Here we go again. What natural phenomenon was observed? Post a formal scientific hypothesis, then experiment that validates your claim. Number 3, highlight the independent and dependent variables that were used in the test. Cite source. Post a null hypothesis that was rejected or falsified. Oh, never mind. From techtarget.com. A gas is a sample of matter that conforms to the shape of a container in which it is held and acquires a uniform density inside the container, even in the presence of gravity, and regardless of the amount of substance in the container. If not confined to a container, gaseous matter, also known as vapor, will disperse into space. Duh! In conclusion, if Catz would have said water is made from boll weevil salts, it would have been more coherent. For fuck's sake, man! Thanks for...
And with that, I'll say a huge, massive, enormous thank you to all of today's debating panel on both Discord, Skype, and indeed the Hangouts on Air regular panel members. If you are watching this on the Nathan Oakley premiering stream, then stay tuned, as there will be an after show to follow. Unfortunately, if you're watching this in the Nathan Oakley 1980 live stream, then this is where we bid you farewell. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley. Stay tuned if you're watching on the premiering stream, and I'll see you all in the next video.
Oh, what a day! What a lovely day!